A rock thrown downward with an initial velocity of v naught equals 8 feet per second from an initial height of h naught equals 80 feet follows an equation for its height in feet as a function of time, y of t equals negative 16t squared minus v naught t plus h naught. Determine the parts A through D. The position function of time, the height in feet as a function of time, is given as negative 16t squared minus v naught minus 8 times t plus h naught plus 80. The first thing we want to determine is A, the velocity as a function of time. The velocity as a function of time is the derivative of the position as a function of time. The first term is a power rule. Bring down the power, multiply with the negative 16, negative 32, t raised to the subtract 1 from the power. The second term is a constant times t. The derivative of that is just the constant. And then the third term is the constant with no t. The derivative of that's a 0. There's our velocity as a function of time. v of t equals negative 32t minus 8. Part B, we want to find the time when it reaches the ground. The ground is defined as a height at 0. So if we take the height as a function of time and set it equal to 0, we can then solve for the time when it reaches the ground. This has a common factor of a negative 8. Let's factor that out. That'll give us a positive 2t squared, a positive 1t, and a negative 10. We can now trinomial factor the 2t squared plus t minus 10. Since it's 2t squared, it'll be a 2t and a t. We need two numbers that multiply to be a negative 10 and add to be a positive 1 after one of them is multiplied by a 2t, notice, in the factorization. Now 10 has divisors of 10 and 1, or 5 and 2. We can try 10 and 1. If we put a 10 here and a 1 here, this will give us a 2t and a 10t, and there's no way those combine to be a positive 1t. We can reverse it around and try the 10 here and the 1 here, and that will give us a 20t and a 1t. There's no way those will combine to be a positive 1t. So it's not that. We can try 2 and 5. If we put the 2 here and the 5 here, that will give us a 10t and a 2t. There's no way those combine to be a positive 1t. We can try the 5 here and the 2 here, and that will give us a 4t and a 5t, and those can combine to be a positive 1 if we have the correct signs. We will want the 5 to remain positive and the 2 to be negative. So we have the 5t and then negative 4t to give us a positive 1 altogether. So this equals to 0, and therefore we have 2t plus 5 equals 0, which means that 2t equals to negative 5, or t equals to negative 5 halves. And we also have t equals to 2 for the other factor. Now times can only be positive, and therefore we only want the positive 2. Our time will be in units of, we can see in the v naught, the units of time are seconds, so 2 seconds. For part C, we want to know the velocity when it reaches the ground. Well, in part A, we have the velocity function of time, and in part B, we have the time when it reaches the ground. That can be plugged in. So v of 2, which will be negative 32 times 2 minus 8. Negative 32 times 2 is negative 64 minus 8, which altogether will give us negative 72. And the units will be the distance units of feet over the time units of seconds. The negative indicates that it's moving downward when it reaches the ground, and that makes sense. It should be a negative. Part D, we want to find the acceleration as a function of time. The acceleration as a function of time is the derivative of the velocity as a function of time, which is therefore the second derivative of the position as a function of time. The velocity as a function of time is in part A if we take the derivative of that. The first term is a constant times t. The derivative of that will be the constant, negative 32. The second term is a constant without a t. The derivative of that will be a 0. The units of acceleration are the distance units of feet over time squared, seconds squared. So we have a negative 32 feet per second squared.